Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be learning the lecture on dynamics of machinery, and the topic is the very first lecture, that is topic is mechanical vibration, the definition, and you are going to understand the types of vibrations as well as the various methods of analysis of vibration. Let us understand first of all what is meant by mechanical vibration. Let us consider you have a turbine which is rotating, assume that it is rotating at high speed. Usually, the materials are made up of elastic in nature. So, the density throughout the material, assume that it's a turbine, the material density is not perfectly uniform. Not perfectly means in the sense it is not 100% uniform. You have at certain locations high density spot, and at certain locations you have low density part. Obviously, what happens is when it is rotating with very high speed, when it is rotating with very high speed, so this leads to centrifugal force, unbalanced centrifugal forces. So these unbalanced centrifugal forces pulling the material away from the center of rotation, and that leads to the vibration. So it's not possible to eliminate the vibrations from the mechanical or dynamic systems. Only you can analyze it and you can reduce the severity of the vibrations by means of various methods of balancing of the machinery. So this is what exactly the definition, and let us understand mechanical vibration by means of a spring mass system. Let us consider a spring with a stiffness K and mass M. When you have bodies, maybe a spring, maybe a circular disc, maybe a turbine, maybe a shaft, maybe a circular disc, all this, it is when it is now, this is in equilibrium. This reference is equilibrium position. It is in equilibrium position. When it is subjected to displace by means of an external force is acting, and from the equilibrium position, it is displaced. And here you can observe carefully, the body will be moving up and down about the mean position. That mean position is your equilibrium position. So this is what exactly in called as vibrations, or you can call it as oscillations also. So the body will be moving about the mean position up and down. So this phenomena is called mechanical vibrations. And let us understand the detailed types of vibrations. Types of vibrations. So here you can classify the vibrations into three important broad categories. I am classifying the first category as free vibrations. The second one is damped one, damped vibrations, and forced vibrations. You have three important types of vibrations. Free vibrations means when you have a spring mass system, only the initial disturbing force is acting. Let us consider a spring with mass m, and it is displaced from the equilibrium by means of a external force. It is initial disturbing force. So because of that, the vibrations are existing. And if you understand the plot between the displacement and the time, so it will be about the mean position, it will be moving up and down. This is what exactly the behavior of the free vibrations. Damped vibrations, here you have a damper whose coefficient of the coefficient is c, and your spring is stiffness is k. It is attached to the mass m. Now this is displaced. Let's say this is attached to this. So here the damper makes that the amplitude of vibration reduces drastically from cycle to cycle. If you understand this phenomena exactly, the graph, your initial amplitude is large, and from cycle to cycle it will decreases, and within a short period of time you are going to have or the vibrations will die out because of this damper, what you have here, damper, right? The forced vibrations, let us look at that forced vibrations. You have a continuous external excitation. Your displacement is downwards, it is mass, and the force is acting, a periodic force is acting. Periodic force is F naught, let us say sine omega t. This is the force and this is the displacement. Because of this external force continuously acting, periodically it is acting on the body, and the vibrations are going to exist continuously. You can see that it is going to be maintained like this. So these are classified depending upon the external force acting only at one instant, and you have a damper in second case, and the force is external force is acting continuously or periodically harmonically on the body. That is what is third type of vibrations. And let us look at that free vibrations further classified. These vibrations are further classified into, you know, you can classify it as longitudinal, it is longitudinal, transverse, transverse, and torsional vibrations. Torsional vibrations. So you have three types of vibrations depending upon the direction of the motion of the particles with respect to the axis. Here longitudinal vibrations, let us see that you have a shaft, slender shaft, a disc is attached to this, and if the vibration is the particles are moving parallel to the axis of the shaft, here the motion is up and down, it is called longitudinal vibrations. If it is exactly perpendicular to the axis, let us say, if it is perpendicular to the axis, the motion is like this, the particles are moving about perpendicular to the axis, it is called transverse vibrations. And the torsional vibrations, as you know, you can represent the shaft, the top view of the shaft is circular in nature, and it is twisted and untwisted. It is going to move like this. Let us say this is angle theta. So you are applying a torque on this so that the circular disc is twisting and untwisting takes place, and that is what is called torsional vibrations. Here, this particular classification, the free vibration classification, purely depending upon the motion of the particles. Here, the particles are moving parallel to the axis of the shaft. It is perpendicular to the axis of the shaft. It is about to the axis of the shaft. Is called torsional vibrations. Thank you for watching this video.